Hello and welcome to my presentation of carrying out the vision-based emotion detection of game players using a program I had created called ERS. In this presentation, we will be looking at the background of the program I had created, which will also explain a little background on the gaming history, the research into the emotion detection of gameplay that had been carried out in the past, the methodology behind my project, which will show the inner workings of the program I had designed for the experiment, which will mean that we'll be looking at the code behind the program, the demo of the program itself working, which will be a short video, the experimentation results collected from the experiment, and finally the conclusion of the project. The background of the project involves a program created by me called ERS, or Emotion Recognition System, and involves detecting the emotions via a webcam, whether used internally or externally, whilst playing the chosen game. The aim of this project is to find out how the length of the gameplay affects the player's emotions. This aim will be met by the following set of objectives, which are to find out the emotion recognition of players during the gameplay, such as happy and sad emotions, and the variations of such emotions during the gameplay, which will look into the intensity of such emotions. The inspiration behind creating the ERS was that I was interested to see what emotional impacts the games had on people as they played the games. Gaming has been around for the last 50 years, since the 1970s, and the demand for games and gaming has been on the increase ever since then, especially during the lockdown period. In fact, according to Statistica, between the 16th and 22nd of March 2020, there had been a total increase of 63% in game sales, which is the same as about 4.3 million games being sold worldwide. However, despite many consumers enjoying the games they play, they don't often truly get to see how the gameplay affects their own emotions. Because of this, the game creators have a harder time creating the games that the consumers want. These issues gave the perfect opportunity to carry out this project. The research behind why I created the ERS for detecting emotions during gameplay was that there had been proven studies that showed the link between the gameplay and the emotions. However, the methods in these studies did not focus on the facial emotions, but rather the psychological emotions, which are known as feelings. Furthermore, the gameplay time was not considered as a key factor in any of the experiments of the studies. I chose Python as the programming language for building the ERS program, as it was a non-specialized programming language, meaning it could be used to create anything. It was very versatile and easy to use, very capable of handling statistical data better than other languages, and has vast libraries and module support. For the emotion detection aspect, I decided to use DeepFace since it's a hybrid face recognition framework which achieves 97% accuracy in terms of identification when compared to other frameworks. Also, it's just easier to implement. For the methodology, we will look at the initialization of the program and camera, drawing a rectangle around the face and mapping emotions to it, creating warnings based off the anger and happy emotions, and the termination of the program. The menu will also be looked at, and also the libraries and modules shown now will be explained later in these parts. The key code behind the program is stored in this function. The front face classifier is first called, before trying to initialize the webcam. Background subtraction is initialized as well after, but will be explained in the next slide. There is a simple check to see if the webcam has been successfully connected or not. Next, in the while loop, background subtraction is applied to the frame to remove the background around the user. DeepFace.analyze carries out the main emotion detection of the face and frame. The face in the frame is then grayscaled for easier detection before passing through the for loop to draw the rectangle around the face using OpenCV. OpenCV is then used in conjunction with DeepFace Analyze to finally map all the 7 emotions to the face. The anger warning prints when the anger emotion exceeds 80%, and the happy message prints when the happy emotion exceeds 70%. The ERS function terminates upon the user clicking the C key. The menu is created using the tkinter module and has buttons which will lead to several options, of which the start button will lead to the function that was mentioned previously. This is the result of the code being implemented, with the emotion detection system on the left and the main menu on the right. The ERS program was used with the chosen game that had never been played before, called Splitgate, for the main experimentation that will be discussed later. You will now see a quick demo of the ERS program working with sample emotions. In the video demo, we can see that I click on the Start button to initialize the emotion detection program, which will open up another window. The program runs and detects the emotions listed on the screen as an example. Note how the messages appeared when I produced the happy and anger emotions. Also note that the video demo is meant to show what possible emotions could be detected during the gameplay in the experiment to follow. In the experiment, the 5 volunteers were asked to play the chosen game in 3 separate sessions of 20, 40 and 60 minutes, whilst their emotions were being recorded. In the 20-minute session, we can see that all the emotions were not that intense, with only volunteers 2 and 4 showing the most anger and fear emotions, and volunteers 1, 3 and 5 showing the most happy emotions. This implies that the volunteers were trying to figure out how the game worked since they hadn't played it before. In the 40-minute session, we can see that most of the emotions have started to increase in intensity, with a significant increase of the anger and fear emotions in volunteers 1 and 5 when compared to the 20-minute session. There has been an increase in the sad emotion in volunteers 3, 4 and 5. However, the happy emotions of all the volunteers have slightly dropped in intensity, which could suggest they are now trying to focus on the gameplay more. Like with the 40-minute session, the 60-minute session shows a further increase in the intensity of most of the emotions, particularly in the anger, fear and sad emotions, which suggests that the volunteers have shown a bit more focus towards the game. On the other hand, though, at the same time, we can see that there is a significant drop in the happy emotions of all the volunteers, which suggests that the gameplay was getting a bit too tiring for our volunteers. In the post-experimentation reviews, we can see that most of the comments made by all the volunteers about the 20, 40 and 60-minute sessions do correlate with most of the emotions produced during the experiment sessions. In the 20-minute session, all the volunteers mentioned that they had an enjoyable time playing the game, and one goes on to mention that they were interested in how the game worked and functioned. When it came to the 40-minute session, 3 of the volunteers mentioned that they still enjoyed the game, but 2 made some interesting comments. One said that they were losing a bit of concentration in the game, whilst the other mentions they were being a bit more agitated when they were killed in the game. Come the 60-minute session, all the volunteers started to feel a bit tired and lost a bit of interest as a result in the game after a while. Overall, the volunteers said that the game was interesting during the shorter time periods, but not so when it came to the 60-minute session. In conclusion, it was enjoyable to utilize the Python programming language to build the ERS from scratch. Using deepface allowed for emotions to be detected as accurately as possible for the experiment to work. The results showed an overall increase in the intensity of the emotions felt from the 20-minute to the 60-minute session, with significant increases in the negative types of emotions, such as anger. Based on the results and analysis of the results, it can be concluded that the longer gameplay has an impact on the player's emotions. The project findings will help the game developers to develop more exciting games that can be completed in a shorter time frame. Implementing this change will minimize the emotional impact video and computer games usually cause. Doing the project has taught me that the games have a unique way of generating emotions based on the content. I wanted the program to be a fully developed application, but unfortunately, issues in the conversion process due to the errors I could not fix prevented me from doing so. Because this experiment required participants to spend over 2 hours of their time to complete the experiment, some of the volunteers ended up pulling out the experiment as they were unable to make that time commitment. In addition to this, some of the volunteers that were chosen decided that this game was not for them and withdrew. This had a significant impact on the number of volunteers I chose for the experiment. If I could try this experiment again, I would try it on a larger sample size to see what impact it would have on the variations on the emotions produced during the gameplay.